June 1943. A soldier lies behind a sand berm outside Gela, Sicily. His Thompson submachine gun is in his hands, and it has stopped firing. The gun cost $45 to manufacture. It required 45 individual parts, each precision machined to exacting tolerances. The receiver was hand-fitted. The trigger group was calibrated. It was, by any standard of American industrial pride, a masterpiece. It was also useless at this moment because it had jammed. The bolt was locked. The sear had seized. He worked the charging handle frantically, trying to clear the stoppage, but the mechanism wouldn't budge. Around him, German soldiers were advancing through the smoke. His Thompson had become a 6-pound paperweight at the exact moment his life depended on it working. The problem was systemic and catastrophic. The Thompson submachine gun had been designed for accuracy and reliability under controlled conditions. It was a weapon born in peacetime thinking, engineered for target ranges and parade grounds. Its complexity was its pride and its fatal weakness. Tight tolerances that produced precision also produced binding when sand got into the mechanism. Intricate trigger systems that felt wonderful to trained shooters became mechanical death traps when exposed to the brutal conditions of actual combat. The gun required constant maintenance. It demanded careful lubrication with specific oils that degraded in extreme conditions. It needed soldiers who understood the delicate synchronization of its many moving parts. On the battlefields of Africa and Italy and the Pacific, where conditions were anything but controlled, the Thompson was failing at an alarming rate. American ordnance plants were producing submachine guns faster than supply lines could deliver them, yet commanders were reporting that significant percentages of those guns were unreliable in actual combat conditions. The Army needed something different, not a better Thompson, something radically new that abandoned precision engineering altogether. The problem was simple: create a submachine gun that cost less, manufactured faster, yet proved more reliable in combat. How could a cheaper weapon outperform one of the most expensive guns in the arsenal? The answer would come not from established designers, but from a radical rethinking of what a weapon needed to be. What if simplicity itself became invincibility? In 1943, as American soldiers struggled with jammed Thompsons, the answer was being forged in Connecticut. The design team was small and focused. Colonel Reuben H. Thompson and engineer George J. Hyde at Bridgeport Ordnance operated under a mandate to design a submachine gun manufacturable in weeks instead of months. The usual design process was abandoned. There would be no elegant solutions, no precision engineering for its own sake. They approached it like industrial engineers, not gunsmiths. They asked, what is the absolute minimum complexity required for reliable fire? The answer was brutal in its simplicity. The Thompson required precision milling of multiple components. The M3 required stamped steel. Almost nothing on the gun was milled. The receiver was stamped from sheet metal. The barrel was sourced from standard pipe manufacturers who already knew how to make tubes in bulk. The firing pin was simplified to the point of barbarity. The trigger assembly was so basic that it seemed almost crude. Loose tolerances were not a compromise born from material shortages, though wartime America certainly faced those. Loose tolerances were a deliberate design choice. They allowed for manufacturing variance. They meant that even if a part wasn't perfectly centered, the gun would still function. When sand got into the mechanism, the loose fit meant the parts could still move. When temperatures dropped or lubricating oil degraded, the gun didn't need perfect synchronization to fire. The receiver required only 9 stamped steel components. A Thompson required dozens of precision-machined parts that had to fit together with exacting precision. The entire gun could be assembled in standard factories that had no experience with weapons manufacturing. Automobile plants could build the M3. Bedframe manufacturers could build the M3. Any factory with stamping machinery could build the M3. The manufacturing process was so simple that semi-skilled workers could handle it. There was no need for precision tooling. There was no need for master gunsmiths. The cost to manufacture was approximately $20 per unit. A Thompson cost $45. The M3 could be produced 5 times faster than a Thompson. In sheer numbers, American industry could manufacture the grease gun at a scale that no other nation could approach. The gun looked like nothing that soldiers had ever carried. It resembled a technician's grease gun from an automotive garage, which was where its nickname originated. The barrel was a simple tube with a break at the end. The receiver was a flat-stamped steel box. The stock was a simple tube that telescoped for compactness. The sights were minimal. The entire gun was stripped down to its absolute functional essence. American officers who first saw the M3 were skeptical. It looked cheap. It looked crude. It looked like a weapon that had been designed by someone who didn't understand guns. What they didn't understand was that design constraint had produced something genuinely revolutionary. By late 1943, M3 grease guns arrived on battlefields in significant numbers. Soldiers who had fought with jammed Thompsons suddenly had guns that worked. The loose tolerances became the secret to reliability. When sand got into the mechanism, the gun didn't jam. When soldiers dragged their guns through mud and water, the M3 kept firing, while Thompsons seized up completely. The combat reports were striking. A patrol armed with M3s engaged German forces with MP-40 submachine guns and captured Thompsons. The Germans' weapons jammed within minutes. The M3 soldiers continued firing without interruption. In the Pacific, Marines reported their grease guns functioned reliably in conditions that destroyed Thompson submachine guns. The humidity, the salt air, the constant exposure to water and mud, the M3 handled everything. The psychological shift among soldiers was profound. Men who initially viewed the grease gun as inferior began to realize they were wrong. It wasn't cheaper because it was inferior. It was cheaper because it was simpler, and simpler meant more reliable. Soldiers began requesting M3s specifically. Officers noticed that combat reports citing weapon failure decreased significantly when units were equipped with grease guns. By 1944, commanders preferred M3s for most combat roles. The technical reasons were clear and undeniable. The Thompson's fire rate was approximately 700 rounds per minute. The M3 achieved 1,000 rounds per minute. Both fired the same .45 caliber ammunition, but the M3 fired more reliably, more consistently, and with fewer mechanical failures. The sear engagement was brutally simple, which made jamming virtually impossible. The bolt action was so loose that dirt couldn't lock it solid. Documented failure rates told the story clearly. Thompson submachine guns experienced failure rates of 3 to 5% per engagement in actual combat conditions. M3 failure rates were less than 0.5%. The crude gun was simply more reliable than the refined gun. Real stories from soldiers who survived the war underscore the difference. A veteran who fought through North Africa, Sicily, Italy, and into Germany credited his M3 grease gun specifically with keeping him alive. He had seen soldiers with Thompsons die not from enemy fire, but from weapons that failed at critical moments. His grease gun never failed, not once, not in 12 months of continuous combat. That wasn't luck. That was design. By the end of World War II, American industry had manufactured more than 600,000 M3 grease guns. The Thompson, which had been the standard submachine gun when the war began, was overshadowed completely. Nearly 1 million Thompsons were produced during the entire war, yet soldiers overwhelmingly preferred the M3 when given the choice. The cultural inversion was complete. What had been dismissed as cheap and crude was now recognized as superior in every meaningful way. The cost advantage was staggering. The M3 cost 1/4 the price of a Thompson to manufacture. That meant American industry could produce vastly more guns. At a time when supply chain constraints strangled every other nation's military production, the United States could equip its forces with unlimited quantities of reliable submachine guns. The economic advantage translated directly into military advantage on the battlefield. The international impact was immediate and profound. British forces began requesting M3s, recognizing the same reliability advantages American soldiers had experienced. Soviet forces captured M3s and incorporated them into their arsenals. After the war, militaries around the world studied the M3's design and adopted similar manufacturing philosophies. The gun designed as a wartime stopgap became the foundation for submachine gun design for the next 50 years. The M3 proved something fundamental about engineering itself. Precision manufacturing wasn't necessary for battlefield reliability. Tight tolerances didn't guarantee performance in real combat conditions. Loose tolerances, simple mechanisms, and forgiving designs could equal or exceed the performance of complex, refined weapons. American industrial philosophy had always emphasized precision and refinement. The grease gun demonstrated that simplicity could be more effective than complexity. The final irony was this: the weapon that soldiers initially dismissed as cheap because it looked like a grease gun became one of the most respected submachine guns of the 20th century. It cost 1/4 the price of a Thompson. It manufactured 5 times faster. It proved more reliable in combat. It changed how the world thought about weapons design and manufacturing. Sometimes the best solution isn't the most sophisticated. Sometimes it's the one simple enough that nothing can break it. In the jungles of the Pacific, the deserts of North Africa, and the forests of Europe, the M3 grease gun proved that brutal simplicity defeats refined complexity.